Good morning to one and all. Yesterday we discussed about the equilibrium constant in terms of the molar concentration, that is Kc. In today's session, we are going to discuss about equilibrium constant in terms of or with respect to partial pressure, partial pressures. Equilibrium constant with respect to partial pressure. So let us take a general equation. Let us take a general equation. A moles of A plus B moles of B gives C moles of C plus D moles of D. So equilibrium constant in terms of or in with respect to partial pressure is Kp. Kp is equal to Kf by Kb, that is equal to products of that is products product of products in terms of partial pressure by the product of reactants in terms of partial pressure. For molar concentration, Kc, product of the products concentration by product of the reactant concentration. But in a partial pressure, product of products in terms of partial pressure by the product of reactants in terms of partial pressure. So Kp is equal to partial pressure of C power C into partial pressure of D power D by partial pressure of A power A into partial pressure of B power B. This is a Kp expression for this general equation. Kp is equal to partial pressure of C power C into partial pressure of D power D by partial pressure of A power A into partial pressure of B power B. So here PC, PD, PA and PB are partial pressures of C, D, A and B, C, D, A and B respectively. And small a, B, C, D are number of moles of the A, B, C, D respectively. Now unit of this Kp, units of Kp, units of Kp is equal to atmosphere power delta N. So usually pressure units are atmosphere power delta N, where delta N is equal to number of moles of products in gaseous state minus number of moles of reactant in a gaseous state. So yesterday already we discussed this delta N value. Delta N is equal to number of moles of the products minus number of moles of the gas or reactants which are present in a gaseous state. So let us take one example of this. N2 plus 3H2, N2 gas plus 3H2 gas gives 2NH3, 2NH3 gas. N2 plus 3H2 gives 2NH3 gas. Now, Kp expression for this reaction, preparation of ammonia, Kp expression. Kp of this reaction, Kp is equal to partial pressure of ammonia coefficient 2, okay, no, P square, right? Divided by partial pressure of nitrogen, coefficient is 1 is there here, and the partial pressure of hydrogen, coefficient is 3. This is a Kp expression for this reaction. Units of this reaction is equal, delta N value is equal. Delta N is equal to 2 minus 4, that is equal to minus 2. Therefore, atmosphere power minus 2. So these are the units for the N2 plus what amount? Uh, listen carefully. Units atmosphere power delta N. Pressure units. Pressure units is atmosphere and delta N. Delta N is equal to number of products minus number of reactants are present in gas state. Present in gas state only. Don't take a solid substance and don't take in a liquid substances. So one more example. I will give one more example. See. PCl5 gas gives PCl3 plus Cl2 gas. Cl2 and PCl3 both are in gas. So Kp expression is equal to partial pressure of PCl3 into partial pressure of chlorine gas by partial pressure of PCl5. This is the Kp expression for this reaction. Now units of this reaction, units. So how to calculate the units? We know units are the atmosphere power delta N. Atmosphere power delta N. Delta N value is equal to number of moles of products which are present in a gas state minus number of moles of reactants which are present in a gas state. That is equal to, so products 1 plus 1, 2, 2 moles minus 1 mole. 2 minus 1 is equal to 1. So delta N value is equal to 1. Therefore, units is equal to atmosphere power 1. Nothing but the atmosphere. Is it clear, Amma? Who asked? Is it clear? Clear? Shall I give the one more example? Okay, now, right. So, last example of this category, last example, H2 plus I2 gives 2HI gas. So, Kp expression is equal to partial pressure of hydrogen iodide power 2 by partial pressure of hydrogen gas into partial pressure of the I2 gas. This is a Kp expression. Units is equal to delta N is equal to products minus reactants moles which are present in a gas state. 2 minus 2 here, 1 plus 1, 2. 2 minus 2 is equal to 0. That is atmosphere power 0 that is equal to 1. So therefore no units for this equation. No units for this equation. But Kp expression is equal to partial pressure of hydrogen gas by partial pressure of hydrogen. Now hydrogen iodide by partial pressure of hydrogen into partial pressure of I2. If I take calcium carbonate solid gives calcium oxide solid plus carbon dioxide gas. For this reaction, see here, Kc expression is equal to only concentration of the CO2. That's it. Because calcium oxide and calcium carbonate both are present in a solid state. Okay, now so for the solid substances, molar concentration is equal to unity. We consider as a one unit. Okay, now that's why 1 into CO2 by 1 you will get only CO2. Okay, Kc is equal to concentration of CO2 and Kp is equal to partial pressure of CO2. That's it. Partial pressure of CO2. This is a Kp expression. This is a Kc expression. Okay, now here units liter moles per liter power delta n, and delta n value is equal to 1 here. So that's way moles per liter. Here atmosphere power delta n units, atmosphere power delta n. Delta n value is equal to 1 as usual. Delta n value is equal to 1 for any reaction. Delta n value doesn't change. Okay, now so here also, okay, now delta n is equal to 1, that therefore units are the atmosphere power 1, that is equal to atmosphere. So this is a equilibrium constant. Okay, equilibrium constant with respect to the molar concentration and with respect to the partial pressure Kc and Kp. Here we consider the molar concentration. Molar concentration is usually keep in a square bracket. It is enclosed in the square brackets. A square bracket. Okay, now molar concentration are enclosed in a square bracket. Anything is keep on, okay, now enclosed in a square bracket or keep on this square bracket. It represents the concentration of A or it represents the concentration of B. So concentration of X, concentration of Y, like that we have to pronounce. In a chemical equilibrium, if you write a partial pressure of X, nothing but this is the pressure of the X, partial pressure of Y, partial pressure of Z, partial pressure of A, partial pressure of B. So this PA, PB, PX, PY, PZ are under the Kp expression. Concentration of A, concentration of B under the Kc expression. So వాయిస్ డిస్టర్బెన్స్ వస్తుందమ్మా, ఎవరు ఒకసారి మ్యూట్ లో పెట్టండి ప్లీజ్. ఆల్ ఆఫ్ యూ కీప్ ఇన్ మ్యూట్ మోడ్. వాయిస్ మ్యూట్ లో పెట్టాలి ప్లీజ్. నెక్స్ట్ a relationship between Kp and Kc. Relationship between Kp and Kc. Relationship between Kp and Kc. Anjali Jadhav. Anjali Jadhav. Anjali Jadhav, please keep in mute. Anjali Jadhav. relationship between Kp and Kc. Okay, we know Kp is equal to equilibrium constant. Equilibrium constant. Kp is equal to equilibrium constant with respect to partial pressure. Partial pressure. Kc is equal to equilibrium constant with respect to molar concentration. Molar concentration. Therefore, Kp-Kc relation is Kp is equal to Kc into RT whole power delta n. Kp is equal to Kc into RT whole power delta n. R is equal to universal gas constant. T is equal to absolute temperature. T is equal to absolute temperature. Delta N is equal to number of moles of gases products minus number of moles of gases reactant. So how do you get this relation Kp is equal to Kc into RT whole power delta N? Let us take the general equation. A moles of A plus B moles of B gives C moles of C plus D moles of D. If we write the Kp expression for this reaction, partial pressure of C power C into partial pressure of D power D by partial pressure of A power A into partial pressure of B power B. Right, this is the Kp expression. So according to the ideal gas equation, PV is equal to nRT. We know this relation. PV is equal to nRT, pressure P is equal to N by V RT, implies P is equal to concentration, number of moles by volume is equal to concentration, number of moles by volume. 1 mole is present in 1 liter, it is 1 molar. Like that, so we take the concentration N by V, number of moles by volume in liter is equal to its concentration or molarity. So here in place of P, partial pressure expression, in place of P we can write a concentration into RT. Concentration of C into RT power C we write. So therefore Kp is equal to concentration of C power C into RT power C, because partial pressure of C is equal to concentration of C into RT power C we will get. The same method, partial pressure of D is equal to concentration of D power D into RT power D by concentration of A power A into RT power A into concentration of B power B into RT power B. Okay, now. So this equation, just just a little bit I am modifying. See here, this equation. So Kp is equal to concentration of C power C into concentration of D power D, concentration of C power C into concentration of D power D by concentration of A power A into concentration of B power B into RT power C into RT power D. So A power M into A power N is equal to A power M plus N, RT power C plus D. And here also RT power A plus B, RT power A plus B. Okay, now. So this RT power A plus B. So this A power M by A power N. A power M by A power N is equal to A power, okay, A power M minus N. Fundamental of mass. Now Kp is equal to concentration of C power C into D power D by A power A into B power B into RT power C plus D minus A plus B, because this A plus B term is moved to the minus you will get. Okay, now. So RT power C plus D minus A plus B, number of moles of products minus number of moles of reactant, that is delta N. So Kp is equal to, this total value is a Kc, this is a Kc expression, Kc into RT power delta N. Understood, girls? Are you follow me? Okay, so okay, no, don't bother about the derivation. Nobody asks the derivation, but just I say want to understand. But you have to remember, what do you remember? Relation between Kp and Kc. That's it. Kp is equal Kc into RT whole power n. We know the fundamental. So P in place of P you have to write Kp. N by V is moved to opposite side, that is Kc, and keep RT power delta n. This is a way to remember. No need to get confusion. Just remember the fundamental equation. That is PV is equal to nRT. We know the fundamental equation. PV is equal to nRT. Right. So P is equal to N by V RT. Therefore, Kp is equal. This is concentration Kc, and keep RT power delta M. Remember this power delta N. So no need of this derivation. But if you want, you can copy it. But finally, if you remember this relation only, Kp is equal to Kc into RT whole power delta N. Is it clear, Amma? Girls, is it clear? Okay, shall I arrange? Shall I arrange it? Okay. So now, Kp Kc relation is a Kp is equal to Kc into RT whole power delta N for the general reaction. Let us take examples. N2 plus 3H2. It is not a general, it is a preparation of ammonia in Haber process. N2 plus 3H2 gives 2NH3 gas. Now, for this reaction, what is a Kp-Kc relation? Kp is equal to Kc into RT whole power delta N. This delta N will decide the Kp-Kc relation. How? This delta N value is equal to 2 minus 4 is equal to minus 2. 2 minus 4, that is equal to minus 2. Therefore, Kp is equal to Kc into RT power minus 2. RT power minus 2 implies Kp is equal to Kc by RT whole square. Now from this, what you understand? Kc is a division with some value. RT value is some value here. Kc is a division with some value. Therefore, Kc is the highest value, Kp is the lowest value. Therefore, the relation is Kp is smaller than Kc. This is the relation. Kp is smaller than Kc. Understood, Amma? Girls, understood? Are you okay now? Are you follow me? So delta n value is equal to negative. Then Kp is smaller than Kc. Remember this. Any equation delta n value is equal to negative. See here, 2SO2 plus O2 gives 2SO3. Gas state, this also gas and this one also gas. 2 minus 3. Delta n is equal to 2 minus 3. 1 plus 2, 3 is equal to minus 1. Now Kp is equal to Kc into RT whole power minus 1. So minus 1, mathematics Kc by RT we can write. Kc by RT, that is equal to Kp. Okay, and Kc is a division with some value. Let us take to understand. Very simple. 100 is equal to 200 by 2. So here Kp value is equal to 100. Kc value is equal to 200. 200 by 2 is equal to 100. Then only both get equalized. So now what you understand here, 200 is more, 100 is less. That's way 200 value is a Kc, 100 value is a Kp. Therefore Kp is smaller than Kc. Kp is smaller than Kc. Otherwise Kc is greater than Kp. Understood now? Okay now. So when the delta n, right, delta n value is a negative, then Kp is smaller than Kc. If case number 2, this is a case number 1. Let us take case number 1. Delta n is equal to positive cases. Next, case number 2. Case number 2. Delta n is equal to positive. For any reaction, delta n is equal to positive value. So, sorry, delta n is equal to, this is negative, sorry, delta n is negative, right? Delta n is equal to negative, this is delta n is equal to positive. So let us take delta n is equal to positive. PCl5 gas gives PCl3 gas plus Cl2 gas. So here delta n value is equal to 2 minus 1. 2 minus 1 is equal to 1. Delta n is equal to positive. So then a relation. Then the relation between Kp and Kc for this reaction. Relation is Kp is equal to Kc into RT power 1. Nothing but Kp is equal to Kc into RT. Now what is the relation? Kc is multiplied by some value, then you will get the Kp. To understand it is a Kp value is equal to 100. To get 100 I am taking a Kc value is 50 and RT value is a 2. 100 is equal to 100. So Kc value is 50, Kp value is 100. Then what you understand here, Kp is greater than Kc. If anything is multiplied, then you will get some value. That multiplied value is a lowest value. Getting value is a highest value. So, okay, delta n value positive for any reactions. Delta n value is equal to positive. Then Kp is greater than Kc. For any reaction, delta n is equal to negative. Kp is smaller than Kc. Last case number 3. In case number 3, delta n is equal to 0. Delta n is equal to 0. Okay, now delta n value is equal to 0. Okay, now then what happened? So let us take H2 plus I2. H2 gas plus I2 gas gives 2HI. H2 plus I2 gives 2HI gas. Delta n value is equal to 2 minus 1 plus 1, 2. 2 minus 2 is equal to 0. Therefore, Kp is equal to Kc into RT whole power 0. RT whole power 0. Therefore, Kp is equal to Kc into RT whole power 0, nothing but something power 0 is equal to 1. Therefore, Kp is equal to Kc. This is the relation. When delta n value is equal to 0, number of moles of products is equal to number of moles of reactant which are present in a gaseous state, then delta n value is equal to 0, then Kp value is equal to Kc. Delta n positive, Kp is greater than Kc. Delta n negative, Kp is smaller than the Kc. Is it clear now? Girls, is it clear? Okay, next, next, equilibrium constant for the general reactions and their multiples. So this concept also most important for the competitive. Equilibrium constant, equilibrium constant, equilibrium constant for a general reactions and their multiple reactions and their multiples. So just apply the common sense for this only. See here, A moles of A plus B moles of B gives C moles of C plus D moles of D. For this reaction, I write the Kc expression products by reactants. Okay, now. So Kc expression is equal to C power C into D power D by A power A into B power B. Okay, now. Let us take reverse of this. C moles of C plus D moles of D gives A moles of A plus B moles of B. So this is a Kc prime because the given reaction equilibrium constant for a general reversible reaction, actually exactly general reversible reaction and their multiples. So A moles of A plus B moles of B, C and D. So this is a reversible reaction. The equilibrium will be attained either sides. If we take the reactants, you will get the products. If we take the products, you will get the reactants. Okay, now the equilibrium will attain either side. That's why if I take a products or reactants, in this reaction these are the product, but in this reaction these are the reactants. So products are come in the reactant side and reactants are come in the product side. So then Kc prime expression is A power A into B power B by C power C into D power D. Then what is the Kc and Kc prime relation? Kc prime is equal to 1 by Kc. Kc prime is equal to 1 by Kc because both are reciprocal in manner. If I reverse this, I will get this. If I reverse this, I will get this. So Kc prime is equal to Kc implies Kc is equal to 1 by Kc prime. 1 by Kc prime. This is the relation. So N2 plus 3H2 gives 2NH3. Kc of this reaction is equal to 49. Okay, now what is the Kc value for the following reaction? What is the Kc value for the following reaction? That is 2NH3 gives N2 plus 3H2. Kc prime. Okay, now what is the equilibrium constant value? Otherwise, simply write here. What is the equilibrium constant? Equilibrium constant value for the following reaction. Then what is the value? What is the value of this reaction? Kc of this reaction is a 49. Let us take this as a Kc prime. Kc prime is equal to what is the value? 1 by Kc. This is a reference equation. This is our requirement equation. If I reverse the fundamental equation or reference equation, I will get the requirement equation. Right? If I reverse it, I will get. So Kc prime is equal to 1 by Kc. That is equal to 1 by 49 is the answer. Got it, Amma? Is it clear to all? Okay, now is it clear to all? Right. One more example. So A moles of A plus B moles of B gives C moles of C plus D moles of D. Okay, now the equilibrium constant is equal to Kc for this reaction. And if I take N into A moles of A plus N into B moles of B gives N into C moles of C plus N into D moles of D. Again, it is multiplied with N factor N. Then, what is a relation between Kc and the Kc prime? For this, equilibrium constant is a Kc prime. What is a Kc prime value? Then, what do you expect here? So, Kc prime, this is our requirement equation. This is our reference. So, okay, by the modification of this reference, you will get the requirement. What you do? Multiply with n. Nothing but Kc prime is equal to Kc power n. All coefficients are come on the power position. Kc prime is equal to Kc power n, or Kc is equal to Kc, okay, now prime all power 1 by n. If it is moved to the opposite side, Kc prime all